Good afternoon. Today we will continue the third unit. So in third unit, we seen in detail about workability and what are all the factors affecting workability. Okay, next we'll see about the measurements. So how to test the workability. Okay, as I told earlier, workability means it deals with the easiness and homogeneity. Easiness means how easy it can be used, okay, how easily it can be mixed, how easily it can be transported, how easily it can be placed, okay, that easiness. Okay, so without difficulty to the labor, how the concrete is workable for the labor in all the stages of constructions. Okay, up to the placement level, okay, this easiness should be ensured, and also it should be homogeneous also. Both the things is very important, the two words easiness and homogeneity. So homogeneity means it should not separate out. Okay, so those things should be ensured in all the conditions. Okay, starting from the mixing to the placing of the concrete. Okay, and what are all the tests we can conduct to measure this workability? Mainly the slum cone test, next VB and compaction factor. Okay, so mostly the slum cone test is widely used everywhere because the apparatus is very light in weight. We can take to the site. Okay, but this compaction factor test and VB test are laboratory oriented. We have to bring the concrete to the lab. Okay, so when compared to these two, slum cone is highly preferred, okay, in many construction site. And with this one we will concentrate on two major topics, segregation and bleeding. Okay, so these two are very important, as I told, the okay, the easiness and homogeneity. Okay, these two things if you're not ensuring, then okay, it will results in the segregation. So what is meant by segregation? The word itself denote it is separation of ingredients in the concrete. So whenever we make a concrete, that homogeneity should be ensured. If it is not homogeneous, okay, then okay, it is like separation of material. Okay, that cohesion won't be there. Cohesion won't be there means we won't get a okay rich mix. Okay, it will be resulting in a weaker mix, thereby it will affect many properties of the concrete. Okay, so why this segregation is happening? So concrete, okay, is made up of different materials which has different specific gravity. So for example, aggregates have different specific gravity, cement will have different specific gravity. Okay, so sand and coarse aggregate also. So with this different specific gravity, if you make a concrete means it has a tendency to separate out. Okay, so here you can see a mix. Okay, in a drum mixer, you can see the separation of the coarse aggregate. The cement paste is been okay near the uh, walls of that drum mixer. So this is an example of segregation. So what are main parameters we have to consider? Okay, when it is okay in terms of segregation means the grading of aggregate. We should always follow the uniform graded aggregate, the size of aggregate, shape, surface texture for binding. Okay, with the cement paste and also the water content, these parameters may play a major role, okay, in terms of segregation. And what type of segregation will occur? Sometimes okay, coarse aggregate will try to separate out, sometimes cement paste alone will separate out. Here you can see the cement paste is separated out, here you can see the coarse aggregate alone coming out. Next you can see the topmost picture where water alone come to the top surface. So this water coming out, okay, is dealt with in another chapter called bleeding. Okay, so and regarding the causes, so what are the main causes for the segregation is that okay, so it is mainly due to the badly proportioned mix. So we may do a nominal mix and design mix. During that time we have to know the properties of the ingredients. For example, aggregate means what is its specific gravity, cement means what is its specific gravity. So with the specific gravity only the mix design proportions are made. If you're not knowing the properties of ingredients, if you make a normal mix means, then okay, it may sometimes result in badly proportioned mix, thereby it cause segregation. Second one, excess water content. So the main causes for the segregation is also by adding more water. If you add more water, then the cohesive nature won't be there. Okay, so thereby separation will happen easily if you add more water. Okay, and also dropping a concrete from height. So whenever you drop a concrete from a height due to its specific gravity, the coarse aggregate will fall down first. Next only the cement matrix. So that also will result in segregation. And also if you are making a closely spaced rebars, okay, the space is not okay enough for the entry of that homogeneous cement matrix, means sometimes the coarse aggregate will be stuck in between the reinforcement. Okay, and also when we are using a sheet, okay, so mainly this sheet is always attached to the RMC, okay, that transport truck. Okay, when you are placing it, if there is any change in direction, suppose the chute is okay along the direction of the flow of concrete, means no worry. Suppose if we make a, just a minute, I will erase it. Suppose if you are making a direction, a change in okay direction for the concrete, suppose by 60 degree or 90 degree, what will happen? All the concrete when it comes, mean the coarse aggregate alone will be gathered at the corners and the remaining material will flow out. Okay, so like this problem will happen if there is a change in direction. Okay, so we should always follow an proper direction. And next one, okay, when we are using a drum mixture which is too old, the blades will be somewhat okay blurred, so that the concrete won't mix properly, okay, and that homogeneity may not be ensured. Okay, so next one, when we are using a conveyor belt or we are taking in a wheelbarrow, okay, it should not have more vibration. The path where we are taking the concrete should be almost leveled. If there is more amount of undulations are there, okay, the concrete will okay encounter some vibration or some disturbance, so thereby segregation can happen. So mainly this belt conveyor where vibration is happening, mean that also will disturb the concrete. Okay, and for that only if they take in a okay RMC a truck, means they will always make a rotation so that the separation or the setting should not happen. And also it should not be too wet. Okay, so when the concrete is too wet, if you do a vibration excessive, means what will happen? Here you can see the bottommost picture, the coarse aggregate alone is settled down, only the cement paste is on the top. Okay, and when you are finishing the concrete also, we should give some time interval for okay some setting. Okay, it is not like as it reaches the initial setting time. So initial setting time is 40 minutes for a PPC, means okay up to some 15 or 20 minutes we have to allow the concrete to settle. Okay, so after that if you do the finishing, means okay then the concrete okay ingredients won't be disturbed a lot. Okay, and what is the remedy? So far as we seen the causes, the main remedy is that we have to follow a proper mix design, and also use the more amount of powder material, which okay in turn okay make the concrete cohesive. So the okay pozzolana material means we have to use more amount of this fly ash, GGBS, okay, and the ricer's gas. Okay, and sometimes you can go for air entraining agent. This air entraining agent plays a major role of okay holding the aggregate in its position. Okay, so the aggregate to aggregate contact, it won't be happening, so that it will form a matrix where okay the aggregates okay won't be disturbed much. So here you can see an air entrained concrete where the bubbles are placed and then the aggregates are easily spaced in that matrix. And next one, we should prevent okay dropping from a height. So here you can see okay if you just drop from a height or due to the placement of the reinforcement, okay it will disturb the concrete homogeneity and coarse aggregate may sometimes stuck up or coarse aggregate will fall first. Those issues will happen. And also when you are doing the vibration, we should not do the vibration for more time. If you do vibration for more time, what will happen? Coarse aggregate will try to settle down. Okay, so those things we should consider okay when we are doing the compaction. So next topic is bleeding. Okay, as I told, bleeding is a part of segregation where water alone will come to the top surface. Okay, if we add excess water, this will take place. Water gain to the top surface. Whenever they made a concrete, we can see a thin layer of water will be deposited, and sometimes it will mix with the cement. Okay, and it is called as latinants. That also will happen. And what is the main causes for bleeding? Bleeding means it relates to the water. So if you add more water, okay, if the concrete is too wet, and then it cause bleeding. Badly proportioning means water also is an important material for proportioning, that also will cause the bleeding. And also if you're not mixing the concrete properly, that also will result in bleeding. So as I told that, okay, lieutenants are scum. Scum means a layer of cement paste. When you add more water, instead of water alone comes to top surface, it will mix with some cement material since it is powder. Okay, and it will be formed as a layer. Once it dries out means you can see this type of layer. Okay, as a small thick layer in milk when we boil come to the top surface, na, like that layer it will be formed onto the concrete surface and it can be easily removed out. Okay, when we walk also it will be abrated and the top surface will try to come out easily. Okay, which results in a weaker concrete surface. Okay, so and another important thing, it will weaker the interfacial zone. So when the water tries to come to the top, okay, what will happen when we are compacting? Okay, the water will try to lock sometimes under the aggregate, so thereby, okay, when it dries up it will form a gap, and also the total strength also will be reduced. Okay, so next one, it also cause the plastic shrinkage also. If you add more water, it come to the top surface, it evaporates immediately. Once the evaporation is very, okay, drastically happening when we make a concrete during an midday. Okay, so it will immediately form an pressure to that, if the restrainment is not, okay, is made, means then it will cause an crack in that due to excessive stress creation. And also as I told, okay, due to the bleeding, what will happen wherever the reinforcement, just a minute, wherever the reinforcement is there, under that the water will try to lock or under the aggregate. Okay, as I told now in previous slide, interfacial transition zone, okay, will be weaker because the water will be, okay, instead of reaching the top surface directly, it will be locked under the aggregate some water. Thereby once it dries up, it will form an, okay, air gap. Okay, so that the bond between the cement matrix and aggregate won't happen, and finally it reduces the strength of the concrete. This is the crack which is due to the plastic shrinkage. See, as soon as you make the concrete, when you come for next day for making arrangement for curing, you can see a long cracks, okay, along the, okay, length of the slab it may be created. Okay, the owner if he see means he'll be suddenly shocked. Okay, why this crack is appearing? That and all due to the excessive water adding. Okay, and it comes to the top surface like bleeding, and in the direction of wind, okay, in the presence of less humidity, and also the high, okay, temperature of the sun. Okay, these are the factors which make this type of plastic shrinkage cracks. Okay, so next class we'll see about hardened concrete. Okay, thank you.